In this video, we're going to be looking at the stable matching problem. I have an example. We're going to go through the algorithm to solve it. We're given all the boys with their preferences, all the girls with their preferences. We want to create a stable matching, so pair up every boy with one girl, such that there's no self-interest to break that pair. Let's go through the algorithm. Each person is initialized as free, and we're going to be doing this male-oriented, so the males are doing the proposing. So while some man is free and hasn't proposed to every woman, so that's all of them, choose such a man M. Let's start with Adam, myself, I guess. W is the first woman on M's list to whom M has not proposed. That's W right now. If W is free, assign M and W to be wed. So I'm going to highlight in blue. So Beth and Adam are engaged. There you go. Skip. Next one. The rest of the if statements are ignored. Bill. Same thing. Bill and Diane get together. Amazing. Bill. Where's Diane? Diane and Bill. There you go. They are now engaged. So I'm highlighting in blue when they engaged here. Now, the next one is Carl and Beth. Now, if W is free, that's not true anymore. Beth is not free anymore. So skip that. If W, so Beth, prefers Carl over Adam, then do that and free Adam. So we're looking here. Beth does prefer Carl, so they're going to get engaged. This is going to break, and that's the switch that we made there. Next one, we can go just to whoever next. Let's go to Dan next. So Dan with Amy, that's fine, right? Dan and Amy. So Amy and Dan, there you go. They can be engaged. And then Eric and Beth. So now, again, Beth is W now. So is W free? No. Does W prefer M to her fiance M prime? That's not possible, right? Because Beth already has her number one choice. Reject. So no, nothing's made here. But what we should be keeping track of is who's rejected to who. So Eric has rejected to Beth, but has proposed to Beth, but is not able to re-propose. It's like Adam has proposed to Beth, but also not able to re-propose. So next one we have is back to Adam, I guess. So the first woman on M's list to whom M has not proposed. So not Beth now, Amy instead. Amy does prefer Adam to the current partner. So they are going to get engaged. And Amy and Dan are going to be broken up. And now Dan is no longer able to propose to Amy anymore. Again, we just keep going through the list. Now Dan is going to propose to Diane. Diane is totally fine with that because Diane currently has her least favorite choice. So I'm going to make that switch. And then Bill and Diane are going to break up. And then Bill can no longer propose to Diane. Eric is also going to propose to Diane. And that's also fine because Diane prefers Eric. So these two are going to break. And Dan can no longer propose to Diane. Back up to the top. Bill is going to propose to Beth. Beth will reject because Beth already has her top choice. Bill can no longer propose to her. Dan will propose to Kara, and that's fine because Kara is not engaged to anybody. Right? That's Kara is free. So Kara and Dan will get together. And moving back on. So Bill and Amy. So Amy will reject because Bill is lower on the list compared to the current fiance. So Bill can no longer propose to Amy. He's the only free man who has not proposed to every woman. So we must continue. Bill will propose to Kara. Kara does prefer Bill, so they will get engaged. So they will get engaged, and Kara will break it off with Dan. Dan can no longer propose to Kara. Dan will propose to Beth. Beth will reject. Beth already has her top choice. Dan will propose to Ellen, and Ellen will. And there is our stable matching. So the point is that we have no unstable pairs, which means there's no situation where, for example, Adam, I won't use my own name. Beth prefers, I don't know, Bill, or Beth prefers Bill over whatever she has right now. And Bill prefers Beth over whatever he has right now. This would be bad because they would just forget about their assignments and then just get together. So that would be an unstable pair. There are no unstable pairs from this algorithm. That is all.